This conference will now be recorded.
Yeah. So are you able to see my screen?
Yes, sir.
Right. Thank you. So today we will now continue the Kubernetes session. So today we will try to understand what are the resources are available inside our Kubernetes. So today we will try to understand that most important top three resources. Those are Kubernetes resources. We have many resources like the most of them is important is pod. We should understand what pod is more deeply and should understand what services are. We have some services like cluster IP, node port, load balancer. There are some services are available inside Kubernetes. So we should understand why these services are required. And then we have a service called namespace. Namespaces also we should understand. And many more are there like a replication controller and many are there. So anyway, let me mention those as well. Replication controller. These will we will learning in coming sessions. Replication controller, ReplicaSet, Demon set. We have deployment. Yesterday we learned about deployment, right? In our PowerPoint, I have shown you deployment. So in the deployment, we have to mention how many pods you require. Okay. Mm, Ingress controller and many are there. But as of now, today we will try to control. We try to understand this top three today. The top three we'll try to understand. So before that, first let's take what is pod and then we continue with the other one. What is a pod? Pod is a, as we studied yesterday, smallest building block, which contains containers. Building block, building block that we can deploy in Kubernetes cluster. So pod can contain one container or more than one container. So pod is must. Without pod, we cannot deploy container individually. The container must go inside a pod. In Docker, the building block is the least smallest building block is container in the Docker, but in Kubernetes, the building block is smallest building block is pod. Our application will be deployed in Kubernetes. Uh, right, it's already correct. Correct. So I will mention like this. Suppose ours is the application, ours is the application, and it in that application we have different services. And I told you yesterday, every service can contain its own front end, its own back end, its own database. So these three containers we can put inside a pod. So that is one service. That is one service inside a pod. So if you want more such containers like or more such pods, then you can create multiple pods if you require. That means one application we can create multiple 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 pods, pod replicas, you can say replicas means same pod. Such pods we can create multiple number of them. For why? What is the reason? For high availability. Same like how we deploy our application in multiple servers. Similar way we deploy our application in multiple pods. No change. Concept is same, requirement is same, but only the uh, location has changed now. Previously it was running inside a virtual machines. Multiple applications used to be running in multiple machines, but here each will be running in different pods. Every pod uh, will contain will assign one IP address. Automatically, whenever a pod is created, it will who will create the pod? Your Kubernetes will create. Every pod will assign one IP address, and if pod crashed for some reason, then Kubernetes will replace it. This is called self-healing. Self-healing. That means manually, as a DevOps engineer, we no need to do anything. We no need to do anything. Right. Then how a pod is created? Same like Docker Compose, we have a YAML file for pods. Also, we have to create our requirement. What container should be there inside the pod? How many containers should be there? Okay, such information you have to mention inside your YAML file. Okay, to create a pod, we have to write a YAML file, YAML or YAML file. So in that you have to mention how the pod should look like, what images pod should have. Images means you have to mention in the YAML file. You have to mention the image name. Why image name? Only then a container will be created. In that container, the image whatever you mentioned in the YAML file, that will be deployed inside that container. And very important thing you should understand, to expose pods for outside access, we need to use Kubernetes service concept. So if you don't know services, then knowing pod is useless. You should understand what services are. Only using services we can, because your pod, I told you, your pod contains the container and the container having the application. Now I want to access the application from my browser. So to get access of that application from your browser, then we have to use Kubernetes services. Only using Kubernetes services we can able to connect our application. Okay, there are three types of services. Okay, there are three types of services. So let me, we have three types of services. First one is cluster IP. Cluster IP. So this cluster IP normally used within the cluster. Suppose there is a node. In that node, there are some four pods are there. If these four pods internally they want to communicate, internally inside the node itself, inside the node itself, then we have to use cluster IP. So this is for to access pods within the cluster, within the cluster. Okay, not outside. Now one pod can communicate with another pod using the cluster IP. One pod, if it want to communicate with another pod, suppose one pod is a application, it contains the application running inside that pod. Now that container want to communicate with another pod, that another pod having some information or database, then it has this container want to communicate with another container, but they will communicate with the pod to pod. So every pod will have its own cluster IP. So using the cluster IP they will communicate. I will explain more thoroughly, but as of now just this is a small definition I'm giving. I will go in depth. So just try to understand whatever I'm trying to explain here. So next is node port. To access pods using public IP, or simply to access pods outside outside mm, the cluster, then we use node port. That means if you want to, outside means nothing but from your browser. If you want to access your container from your browser, then you have to use node port. Node port is the way. So node port will have some, it will have its own IP address. Using that IP address, that means for example we have 3 servers or 3 nodes, right? Every node will have its own IP, right? So this is a node now. This is one node is another node. This is node nothing but your physical machine or virtual EC2 instance. So this EC2 instance will have its own public IP. This also will have its own public IP, right? So node port allows you to access your pod, one of the pod, using the node IP address, public IP address, right? That we'll see with an example. We'll see that. So whenever you want to access your application which is running inside a pod, then you have to use node port. And one important thing you should understand before I go to another type, why we need cluster IP actually? Because we already have pod, right? We already have pod will have automatically a IP address is given to it. So every pod will have assigned one IP address, right? Then why again we require cluster IP? Because one pod already having IP address, then if another pod want to communicate with this pod, then they can communicate with IP addresses. Because every pod will have its own IP address, they can communicate with IP address. But still why we have, on top of it, why we have cluster IP? Because the reason is that I told you that if pod crashed for some reason, then Kubernetes will replace it. When Kubernetes replaces the crashed pod, then a new IP address will be generated. So the previous IP will not be there, the new IP will be given to it. That means these IP addresses are not reliable. They are not reliable. We cannot depend on these IP addresses because the pod may exist, may not exist after some time in future, we don't know. That is the reason we use cluster IP. Cluster IP will never change. Even the pods deleted, created, no problem. But the pods, whenever they want to communicate with other pod, they have to rely on the cluster IP. Whenever the cluster IP having IP, the IP will not change. But the cluster IP will be on top of your pod IP. So internally the pod may destroyed, maybe create a new one, no worries. The other pod, whenever it want to communicate with this pod, the other pod will communicate with using the cluster IP. Then cluster IP will transfer that request to your pod. So it's a wrapper over your pod. It's a wrapper actually. Then node port. Node port, I told you what is that. Node port is nothing but your node's IP address. Node's IP address. So from your browser, whenever you want to communicate with your application, then you have to use your IP address of your node port. Sorry, your node. But this node port, the name saying node port. Why this port here? Here it is IP and here it is saying port. Node is okay. Node is nothing but your node IP address. What is port then? So node port will give you a unique port number, a unique port number. So node port says that okay, you can access your application which is running in the pod, but use this port number. So use your public IP of this node colon and use this port number. Then it will give a unique port number. So that port number we can decide which port number to give. We can decide. The port number normally ranges from 30,000 to 30,000, 32,767. That is a range. I will show you anyway. So that is a range. The port, it will give port number. That means every port you can access your node with a node public IP colon the port number which the node port will give. So to access pods outside the cluster, then we use, okay, to access pods outside the cluster, then we use node port. Okay, but here also there's a problem, right? So what if this node itself crashes? That is the reason we have cluster of nodes. Multiple nodes will be there. Why we have multiple nodes? Because the pod one running here, the same pod may be running in another node as well. So that way they will design they architect the application. They will not depend on one node. All their containers will not be running in one node. The application will be running in containers, of course, but they are running in multiple servers. Why why because if one node crashed, no problem, the other node will have their containers running in another healthy node. Okay, now again we know we cannot depend on node port. Why because the node port is depending on the IP address of this node, and this node might crash. Then when again, of course, your Kubernetes will immediately create one more new node will be created, but again when it is created, the IP address will change. That is the reason we cannot rely on node port as well. Then we have to rely on what? Then we have to rely on load balancer. Load balancer. So we already learned about what is load balancer in your previous sessions, right? So load balancer, taken a class on our AWS cloud. The same rules applies here. So all your requests coming from the internet, from the browser, will goes to your load balancer, and load balancer will check which node is healthy, which node is busy, which is not busy. Everything your load balancer will take care, and whichever node is not busy, to that the request will be forwarded. So here also in Kubernetes we have a service called load balancer to distribute the traffic to pod replicas. Okay, so one more type is there, one more service resource is there in our what you call Kubernetes, that is namespace. But let me complete these three items today. If time left, then I will go with our what do you call namespace. So before I elaborate these things, let me explain you this with some pictures. So this is what I was trying to say. This is your cluster. This is a cluster IP. So these are node 1, node 2, node 3. In every node means your server, one node. In that we have multiple applications running inside your node. As of now I am showing only one pod. There could be multiple pods. So whenever in the node 3 there is a pod running, if this pod want to communicate with the pod running in the node 1, then the request has to go via your cluster IP service. So the request has to be given to your cluster IP, then cluster IP will take care of connecting you to that pod to the right pod. So if second node want to communicate with the other node, or first node want to communicate with node 2, the pod running in the node 2, then they have to depend on the cluster's IP service only. And if you take cluster node port here, you see here there is a node port service running here. So outside, from external client, from outside we will connect something like out. Suppose there is a node 1 having its own IP address, right? So how to connect it? You see http// node 1 colon 30,007. So if you want to connect other second node, then you have to give the second node's public IP, that is node 2. I'm saying node 2, but you should give the node 2's public IP colon 30,097. The port number will not change, the port number will be same, only the IP address will be different. So like this, if you want to connect the third node, then you have to use the node 3. Still your port number will not change, the port number is node port, that is 30,007. So every node will have there is, so every request go to the node port which is connected to each node. Then internal again they will internally node port will communicate with their cluster IP, and that way the request will be forwarded. And this is a load balancer. So previously we are connecting directly using the node port, using the node port, but now you see we are using DNS. So DNS, if you remember, domain name service, when you create load balancer will give a URL. That URL we will use. You see, the external client is not using your node 1 or node 2 like that. He is not using node 1, node 2 like that. He directly using the DNS number, a DNS URL. How we get that? Whenever load balancer is created, load balancer will provide a URL. That common URL you have to use in your browser, which we did in our previous sessions. Okay, just try to recollect. No problem. Anyway, we will be doing that anyway practically. It's all things whatever I'm explaining, everything we'll do practically. So your external client now connects, uses your DNS provided by your load balancer. Now the request goes through your load balancer, and load balancer will then checks which is busy, which service, which node is healthy, which node is not healthy, which is busy, which is not busy. Everything it will have its own algorithm. Basing on that, it will try to connect to the nodes, and the request should be forwarded to your respective node port, and node port internally forward that to cluster IP, and cluster IP will forward that request to your pod, and pod will send that request to the respective container. So this way, the communication will happen. Or more still, with some beautiful colors, then let me show you the same thing in a colorful way. So this is a cluster IP. So you see here, it's all is a internal is happening inside a node, one node. Suppose there is one pod, there is another pod. Now this pod want to communicate with this pod, then the pod request this pod, second pod should connect to the cluster IP service. And if this pod want to communicate with this pod, then this has to communicate, request should go to the cluster IP service, this internal traffic. And what is this in target port? See, I told you every pod contains container. Container is running. Suppose if you take our Java application, our Java yesterday we in Docker Compose we run a shopping site application. Some shopping site application is deployed, right, using Tomcat. So when we using Tomcat, port number 8080 is exposed, right? So that the whatever your container is, whenever you want to connect to your container, we have to use 8080, right? So that you have to mention like your target port. So we are saying that use my target port, that is 8080. So here this pod, whenever this pod want to communicate with your container, it does not know your target port, but it knows the port number. So this is a port number. It's like a port forwarding. In the port forwarding, what we did, host port colon container port. This port here you seeing in the above, this is called the host port. So this port number can be anything, but this port will forward to your target port. Similarly, every pod will be like this only, port and target port. That we'll see. That will I will explain. If you don't understand, no problem. Try your best how much you can understand. Anyway, slowly will when seeing the YAML content, and when I'm mapping over here in the diagram, then you will understand everything. No problem. And this is a node port. You see node port traffic coming from the external traffic. You see outside, that is from the browser, from the internet. It's coming to the your cluster, coming from the outside to your node port. This is a node port. Node port internally connects your service, and in the service connects internally your pod. The same diagram, but we have extra node port, an extra node port on top of it. This is your node. This complete physical server machine, physical machine, or your EC2 instance. And finally your load balancer. So in no space, so simple short traffic coming from the internet, and load balancer will forward the request to your node port service, and it will internally connects to your respective pods, right? So now let us understand how can I create a pod manifest. To create a pod, we have to write a YAML file, right? So how can we create it? So once we know that, then we'll try to understand how to can we create a cluster IP service, how can we create a node port, load balancer using the YAML file. So those syntaxes we try to understand. Okay, so if you understand the syntaxes, then writing the coding is very simple. I mean to say, running the application is very simple. Kubernetes manifest, we say manifest YAML syntax. So YAML file always starts with 3 hyphens. It always starts with 3 hyphens, and then here there will be different sections. Actually, major sections are 4. First section is the version, that is API version. API version. API means application programming interface. So these are all actually we call them as APIs. Actually, these are nothing but small programs. Pod is a program. Everything is a program actually. But end user like DevOps engineer, they don't know programming. So in short, what the Kubernetes is saying is that don't worry about APIs versions, those things. Just give us a number, which version you are using. There could be different versions. So which version you want to use, the version number you have to give. So API version and a colon, and you have to give the version number here. Version number. And then next section comes is kind. Kind means what type of service you want to use, or you want to use. So whatever we mentioned here, right? Here you mentioned services, right? What type of service you want to use? Pod, services, namespace, replica. Which one you want to use? Which one you want? Which service you are going to create? Let me know. So that is the meaning of that. So service or resource name. Resource name. And then metadata. Metadata means data about data. So here we will mention like when this service is created, what name you want to give. When this service is created, what name, any nickname, any name you can give. And then we yesterday in the PowerPoint we understood, gone through two terminologies like selector, label, right? So those things also we mentioned inside the metadata. But practically how to use label and selector, when we using service with pod, then you can understand what is label, what is selector exactly. But as of now, remember, we are using selector and labels in a moment. But in metadata, those details we have to provide. What is an application name? Okay, what is the label name? Those metadata you have to provide. Okay, and then comes your next important thing is spec or specifications. Spec, in short, we have to write specifications. Spec like that, it's nothing but your specifications, what it contains. Here exactly you have to mention what you have to mention. Oh, how many containers you want to create inside the pod, right? How many containers you want to create inside the pod, right? Right, like first example, list of containers, list of containers, right? Container name, container image name, exactly. Container image name. Okay, what is the image name? Okay, port details, port details. Those things you have to provide under your specification. In the metadata, like now, name of the service, any name, right? And labels, labels if required, if you want to provide, but not mandatory. You can leave it if you want. Don't, if you don't want to enter, leave it, no problem. Just but not mandatory. But under specifications, you have to mention compulsorily how many containers you want to create, what container you want to create, like that you have to mention. Okay. So for example, if you remember, we have created in a Docker hub, we have our image, for example. Now this image, my image, I want to deploy this. I want to deploy in my container pod. The pod, of course, containers will be there. When I say I want to deploy in a pod, means you should understand that it contains container. This image will running inside that container. That you should understand. Don't confuse. Okay. So this one I want to run inside my pod. Then how can I write a YAML file for this request? Okay. So for that, you can say, let me write a YAML script. This we will execute when we create our, when we set up our Kubernetes. Okay. At the time, I will run this code. So okay. Hyphen hyphen hyphen. Then API version. API version by default it will be, as of now, it will be V1, version 1. And then kind. So what we are going to create, I'm going to create pod, right? So capital P O D, small O D, no capitals, only P is capital, right? Pod. And metadata. Metadata, you can give your name is two spaces and name colon. Here I can give any name, so I will say shopping site, some name, you can give any name, no problem. Labels, here you have to use the labels colon, labels colon, and two spaces. Now here you have to give some, any random key colon and value, something. shopping app. I'll say shopping app, or in short I'll say hyphen shopping app. Why I use labels here? Why this app? This name you can give anything. This name according to your application name, you can give anything, no problem. But why labels? That you will not understand now immediately, but as of now I'm writing it down. Okay, I will use it where I when I'm using it, then you will understand. Okay, but as of now keep it there. Right. Then go to specs. Spec. In the spec we have to, it's a in the spec now we have to declare our containers. Two spaces, containers. There could be multiple containers, so that is the reason the name is plural, not container, it's containers, it's an array actually. Two spaces, or I think it's a manage, yeah, it's on the same level. Okay, in the containers you have to mention the name of this container, hyphen name. What is the name of container? So I will say you can give any name, you can give any name, no problem. So I will say shopping app container. Right, now in this, now under name, what is the image? Where is the image? I have to mention it. It is inside, it is here, it is here. I want to use this complete name in my path. So you have to mention like this. Then what happens when you run this YAML file? It will connect to our Docker Hub and it will pull the image from your Docker Hub. Okay, that's it. That is the meaning of that. Next, okay, your container is pulled now. In the container, what is a port number? What is a port number to connect? Then you have to say ports hyphen hyphen container port, container capital PORT, container port colon 8080. That's it. This is your example. Version number, what type of resource it is, metadata, what is its name, shopping site, these things. Okay, these things, this one I will explain you when you create a service. When I'm creating these services, at that time you will feel it, you will sense it why we are using it. Okay, then spec containers hyphen any name you can give, any name you can give, and this is most important, which image you want to pull, and what is the port number, or the port number. Right, now this is a program YAML file, that is fine. Now how can I, once if I installed Kubernetes, then how can I tell my Kubernetes to create a pod, and that pod create a container, and in that container pull this image and deploy? How can I tell to my Kubernetes? Then we have to use a command dollar. Before that, let me write the comment here: create pod. Okay, using the manifest file. Okay, then you name is this is this, you name it something like shopping. Okay, shopping app something, or shopping pod, you can say whatever you want, no problem. This is a file name. Okay, this is a file name for example. Then you have to run the command like dollar kubectl apply is a command. And what is a file name? Hyphen f like docker file. If you change the docker file name, then you can give hyphen f, right? Same way, docker hyphen f and the YAML file name or manifest file name. So here I should say dollar kubectl. So do you remember what is kubectl? This that is a that is what, that is a way we communicate with our API server, with your app API server, right? This is your kubectl, you see, like docker command, like a docker run I'm doing now. Like that you have to use kubectl. Now whatever file you are giving, that file will go to your API server. The whatever commands we have written inside the YAML file, those will be given to your API server. Then onwards your master node will take care, it will run the show, right? So here kubectl, I should say apply and then what is application, what is YAML file name, this is the YAML file name, this one you have to give. So now immediately the pod will be created. Now suppose I want to see the pod is created or not. Check pods in Kubernetes cluster. Then how to check? You should say kubectl again, same like no, we used to do docker command at docker run, docker build, right? So all these commands when you executed, where it is used to go to your docker engine, right? Docker engine or docker daemon, right? Or docker engine which is running inside your server, right? So the same way this docker kubectl, instead of docker you should use kubectl kubectl. Now I want to check, I want to see, I want my pods to be displayed. Then I should say get pods, all small letters, kubectl get pods. Then the request goes to your API server, API server, okay, running in the master node or control plane. So when you say give select get pods, then the request goes to API server, and API server will immediately displays you the list of pods. Whatever pod is created, that pod will be created. So more commands are there, but without showing you practically, you won't find interesting. I will stop showing you more commands. That is enough actually. So now let us understand the services now. Okay. While doing practical, I will add more commands here, and then we will work on them. Practically work on them. Let's understand cluster IP now. Services. Again, we are now pod is, that is about how to create a YAML file for the pod. Now try to understand how to create a what do you call YAML file for a cluster IP. Okay, so to expose pods inside the cluster with the fixed IP address, then we use the cluster IP service, cluster service. One moment, please. Okay, sorry. So for that purpose, I already discussed these things. So cluster IP will generate a IP address for the pods. As I discussed already, cluster IP will not changed even if pods are recreated. Right now, to expose the pods using a service, it can be any service. Okay, we always have to write a YAML file. We will create Kubernetes manifest YAML file. So how to write YAML file? Example hyphen hyphen, same like we did before. Okay, same like we did before. Here hyphen hyphen, then YAML file, then API version colon version 1, enter kind. Kind this time the kind is not pod, this time it is a service type, it is a service kind. You have to write service, it's a service resource. And then metadata colon, you can give any metadata name, suppose two spaces, name, shopping. What name you have used? Shopping site, right? One moment please. Shopping, you can give any name, shopping site you can give. See, name is no rule, whether you used it already, we have not used it already, no worries at all. Just give some name to this shopping site service. You can say something like service, because you are writing a service, right? Then you have to give specifications, spec. These four sections will not change. Now you have to write the type. What type? See, previously we don't have type, you see. This is different. Here we don't have type, here we have containers. The specifications for pod is different, the specification for services is different, that you should understand. Okay. Now, okay, you want to create a service, but what type of service you want to create? Is it a node port, cluster IP, or load balancer? It is a cluster IP, then you have to mention it, cluster IP. I want to create a cluster IP. Fine. So here you should understand. Okay, as per this picture, this cluster IP should map to which pod? Here, when you have to mention to the cluster IP which pod it should match, map to which pod. That means if any pod want to communicate with your pod, then the pod will request your cluster IP, then the cluster IP should forward that request to your pod, right? Then the cluster IP should map to which pod. So for that reason only we have created a label, right? If you remember, we have created label here, label, right? This label name I can use, this label name whatever I used here, that you can use in our cluster service YAML file. How can I use it? How can I refer this? Copy this. Okay, just come down here. After type you should say selector. Yesterday we come to this, we heard first time about this selector and labels. So selector, then enter, then two spaces, and paste the label name here. It is nothing but here in the YAML file how to write comments, hash symbol. This is the pod label which we have created under label. Okay, so it is we'll remove this. Okay, pod label which we have created under labels. Okay, in pod, right? Now what happens when you say select a app, this is a key and this is a key, value, then your cluster IP will map automatically to your pod. So whatever request coming to your cluster IP will be forwarded to your pod. That is the reason we use label and cluster IP, right? And then what next we have to do? Okay, if request is coming, the it is a host port, like for this pod, for this pod we have to give a host port, something like host port, and that port will be forwarded to your target port. As if this port is as if I am connecting this pod from the browser. From when you are connecting from the browser, you have to give the host port, right? Similarly, this pod when connecting to your cluster IP, it will not directly connect to your, it will not directly connect to your container port. It will connect to your host port kind of port. It's like a host port. So that we have to mention what is the port and what is the target port. These two details we have to mention in our service under ports section. How? Enter. Here it is under it is selector, right? Next, exactly below selector type, we have given type and selector. Now you have to give ports colon, right? Now you have to say under ports hyphen, it is saying ports. Whenever s is there, it is plural, like containers. That means you can have multiple containers here, you can declare multiple containers. Similarly, you can create multiple ports. So first port hyphen hyphen, sorry, space, the port number. Port, you can give any port number, you can give 53, 50, C4, anything you can give, no problem. Host name can be anything, but the 54 you have to use when you, 54 you have to use this whenever this pod connecting to this, want to connect to this pod, then it has to use the same port whatever we are giving here, the port number. Okay, here I will give some number 80, and here target port. Our Tomcat runs on 8080 internally in the container, so it should give that port number 8080. So how to end a YAML file? You have to put three dots. It's the meaning that it's the end of the YAML file. Even you don't put, no problem, it's okay. Please let me know if you have any confusion in these two YAML files. Okay, we'll practically, when we'll do it practically, it will be see more interesting. But as of now, same way, how to create the service now, right? Create the Kubernetes service. The service could be anything service. There is no special syntax for each service. The syntax is same, but again the same. Kubectl, same thing. Kubectl, no change, no confusions here. And file name. What is the file name? So here I can give some file name, right? Something. Here I will say something like uh, shopping app service or svc dot yaml. You can give YAML, both are fine. Okay, anything is fine, your wish. Use this one here. That's it. Now, how can I see my services? Like get pods, I can use kubectl. Show me all the services. So I should say get services. Get service. Just get service. No services. Get service. Okay. To display all the running services. Okay. That is fine. Hope you're understanding. Now come to notepad. If you understand this theory, then only you can feel Kubernetes very easy, right? So please listen this again if you're in confusion. So notepad, as I already informed you, right? As I already told you, when we expose our when whenever we want to expose our pods using pods to external external, uh, we want to expose our pods to external, we want to access our pods from external source. Okay, then we have to use notepad, right? We can access our pods using worker node. See, worker node or node, both are same, are simply nodes. Okay, worker node both are same. Worker nodes, mm, public IP in which our pod is running, right? So we can access our pods using worker nodes IP address, right? How the syntax looks like? Example, URL to access our pod will be like this: http hyphen hyphen your worker node public IP okay, colon, node port, the port number, whatever you give in the node port, okay, the port number you have to give. And what is the application name? In the Tomcat, what is the application running? The port, the application name. That is something shopping site, something is different. I have to change it. It's very lengthy. Shopping site something. I will change it later. The application name, whichever we have given in our POM file. In the POM file, we given the application name, right? That name you have to refer here, right? So how to write this? How to write the YAML file? Here, node port, shopping site, node port, something like SVS. Sorry, YAML. So everything is same, no change. Some change I have to do. Copy this everything, paste here. Kind is same, no change. This is same. Only type will change. This type will be node port. Type will be node port. And then selector. Of course, the same selector. Which port to be selected. You can give the selector name and ports. Target port. And on top of it, you have to give one more port. The one more port that you give which you use here when accessing here. Colon whatever port number you give, right? That port number you have to give. So here you can give something like node port, small n, node port, capital P, colon, some 3 something 3100 something like that. It is lakhs, right? 30,100 something. Actually, the range of the node port is range is 30,000 to 32,767. This is the range actually. In this range only you have to use. Okay. So this way you have to queue. Now what happens now? Then you can use this port number, and you have to use that port number. You have to copy paste here the port number, and you have to use the public IP of the node, right? And you may be getting some doubt, right? How can I know that where my service is running, in which node it is running, right? In that case, you can give a command somewhere here. I will add here to to know, yeah, to know in which node our pod is running. Then you can give a command like, not only for that purpose, you can use it for any other purpose. So, but one of the purpose immediately I required is I want to see where my, the same command get pods only, but I want more description, more details, like where it is running. Hyphen o you have to give, hyphen o wide is the command you have to give. When you give pods hyphen o and wide, then it will show you in which node it is running. So basing on that, once you know the which node it is running, then you can get the public IP of that node, and you can prepare this URL, and you can access it in your browser. Any questions here, please? Today we'll end with one more service and we'll end here. Okay. Tomorrow we'll see namespaces. So now load balancer. And one moment, before you people are there, or how many are there? How many left? 6 members are there. Swaraj, Shibin, yeah, fine. So so I have two options here for you. Shall we connect on weekend, or shall we connect? Shall we shift back to 9 a.m. in the morning, 9 to 10:30? Which is preferable? I mean to say Monday to Friday, 9 to 10:30, that you want, or weekend sessions shall I take? that is tomorrow and Sunday, which is feasible. Just ping here in the chat box. I'm waiting for your response, so that after seeing your response, I will continue with load balancer. Clearly mention weekends are weekdays from 9 to 10:30. Weekday 9 to 10:30. Swaraj, okay. Please be hurry. 9 to 10:30. Revanthi, okay. Shibin, can you make it up? I know you cannot make it up, but can is it possible for few more days? Maybe another week, maybe one more week or 10 days maximum. Naveen, I didn't receive your response. Shibin, take weekend class for tomorrow and after that it's fine. Take weekend class for tomorrow and after that it's
Yeah, hi Mother.
fine.
I actually was typing, that's why I'm not able to reply you. Yeah, like you can, as decided, you can take classes for tomorrow and day after tomorrow. After that, you can continue with 9 to 10:30. So no issue for me.
Okay, but you want tomorrow?
Yeah,
Okay, no, I am expecting that you people know get a good time for you as for me also. You can practice and I also can prepare some other things for my office things. That's what I'm thinking actually. So weekends, no, if you have spent weekend also, when then practicing also important, right? So okay. Mm-hmm.
Sir, however, the syllabus is little left only. So better only if you take next week 9 to 10:30, then it would be fine, I think.
Okay, okay. Mm. Actually, to be honest with you, some of them want to be finished it early. So that is the reason I'm thinking. Otherwise, no issues. Um, mhm. It's a dilemma now. So, okay, whoever not voted for tomorrow, I'm asking you all, can you manage at least for this 1 week, tomorrow and Sunday? I will take class only this week. Next week, I will not take. If required, I will, let's see, but only this week from 9 to 10. I will take 1 hour, Saturday 9 to 10 and Sunday 9 to 10. Because we are anyway nearing actually. We are already nearing the course and by this week and mostly by next week I'm expecting the course will be completed. After that we will have some discussions, general discussions about preparing a resume, and also we have to do some 2 3 projects also, so where we can uh, communicate with, where we can create our CI/CD pipeline using a Jenkins and with the Docker. Those things also we have to do, but the course will be completed mostly by next week. And for remaining, like Naveen, Revanthi, for you we have other course, I know. After after completing this AWS with DevOps, then we start our remaining part. Don't worry about it, okay? Just I want to I'm keeping in mind other students like Rajesh, Shibin, Suraj. So weekday is only fine, sir. Shibin, what do you say? Most of them actually, I know what happens, Shibin. I'm not taking weekends, why? Because I taken Linux classes once actually. So at that time, what happened? Few people left, and that is okay. That is Linux. That's not important. But this is Kubernetes, right? If they miss, then that's a problem. Already we have strength is coming down. Mm, what do you say, Shibin?
yeah, it's completely your call, Madan. What you say, it's okay for me.
No, no,
No
no,
issues.
no, no, no. I don't want to take my call because I don't want to dominate. I respect your views as well. So, Shibin, I request you, don't worry about the course completion. Even Swaraj, don't worry about this course completion. Okay, we will complete. We will be completing on time. Just I thought you are enjoying it. Uh, But if you want it very fast, then I will take from Monday from 9. Shivin, let me know. I know you, for you 9 to 10:30 is not suitable for you. For you it is suitable from 9:30. But for this 1 week, can you adjust from 9 to 10:30, please? So,
Yeah, yeah. But then I can adjust from 9 to 10:30. No issues. You can continue.
oh, great, 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 great. Thank you, Shivin. Thank you very much. That helps a lot actually, because I want everybody included actually. Don't think otherwise. Thank you very much. So, weekend we will not take class, but from Monday onwards 9 to 10:30 we will take. Okay, 9 to 10:30, so that we will complete the core syllabus as early as possible. Okay, yeah, thank you very much. Let's continue with our load balancer and we'll complete the session for today. I already explained load balancer. So same thing, it is used to expose our pods or pods outside the cluster. Okay, same like node pod, only outside the cluster. So because anyway we are using EKS, we are going Amazon EKS service, then when we use load balancer, then a load balancer service, a load balancer service will be created on our AWS cloud. Okay, in the cloud it will be created. And as I told you, whenever load balancer is created, a DNS will be created for that. A DNS will be provided by load balancer. If you recollect our previous session, you will get a DNS. So using the load balancer URL, we can access our application. That means here in notepad, what we did, we used our notepad IP and our notepad number, but here not required. Your load balancer will take care everything. So you just have to create the load balancer, and load balancer will take the rest and take care of the rest of the things. So for that reason, your what you call, your YAML file looks something different. Yeah, this time this is using notepad. I will say here something like load balancer. Okay, or I'll say LB. Okay, here that note, everything will be same. Everything will be same. The only change is your type, that is load balancer, capital letter, capital L, capital B, load balancer. And since we don't require your node port, right, any not required, only port and target is enough. Remove this. That's all. That's all you have to do. And remaining everything is same, the same command. Okay, here, okay, I forgot to tell you where is that command. You have to use the same command. You have to use the same command to get the list of the services. Once you create it, you have to run the command like this. Same service, no change. Commands are same, right? Here is your LB and here is your file name is different. Use this file. That's it. And get the services. When you run the services, you will get it. I'm sorry. You can use services as well. You can use another command, or you can also use SVC also. SVC. Both are fine. Service or SVC is fine. Both are fine. How to access? Accessing our application, then we have to use, what is the URL? Your load balancer DNS, whatever your load balancer provides, load balancer -DNS name, that it will provide you. Okay, slash, then your app name, Java, whatever app or Java application we deployed, a shopping site, the shopping site name, something like shopping site, that name. That's it. So today we will end. On Monday we'll continue with namespaces, and on Monday we'll see all this practically. We'll deploy all this practically, and then we go to namespaces, and also using namespaces what advantages we get, that we try to understand, and also we deploy namespace as well. Okay, thank you very much. We'll connect on Monday at 9 a.m. Please do not forget, join at 9 a.m. sharply. Thank you. Take care. Happy weekend.
Thank you,